Hi all, welcome back. So this is the last video for today's lecture. I finished the slide. I just want to go through some questions from this tutorial. Basically, this tutorial are the compilations of selected final year exam questions. Okay, so that's why I didn't put any sample of FYE in my slide. Okay, they are here in this tutorial. Okay, let's look at the first question. Okay, so radio digital modulation technique enables the transportation of digital pulses over analog carrier. The three basic radio digital modulation techniques are known as ASK, FSK, and PSK. Explain the general principles of ASK, FSK, and PSK techniques. Okay, this one is already mentioned in the lecture. Okay, and then okay, next, sketch time domain representation of pulses. So you're given pulse, you need to this is our information signal or digital signal. You need to sketch what are the outputs, yeah, for ASK, FSK, and PSK. Okay. Okay, the next question. Explain baud rate. This one we will discuss next week, inshallah. Okay, and then ASK method can be used in a simple remote car system which operating radio frequency around 400 megahertz. With the aid of block diagram, design a simple ASK transmitter for this application and describe how it works. Okay, so you know the ASK transmitter, right? Okay, so I've shown you in the lecture the transmitter for ASK. So you can use some kind of switch, something like that. This is one example. So simple, you can just use like some kind of switch where this switch is controlled by our information signal 1 or 0. That means 1, the circuit is operated and the carrier frequency, which is 400 megahertz, will be transmitted. Okay, so you can refer to the block diagram of ASK using switch. Okay, define the term bit error rate. Right, this one I've also explained. It's just the error bits divided, or the difference between the sent and receive bits divided by the total bits. Okay, and then this one you are given the bandwidth of your FSK, then show the spectrum. But it says here up to just first harmonics, that's the fundamental frequency. So you need to label in a diagram which one is your FM, your the 2 delta F. You can assume what is your FM value here because it's not given. Okay, the transmission bit rate, you know, it's 2 FM. The constellation diagram, this one in our next lecture. Okay, and this is calculation of PE. A binary receiver system receive 1 megabit per second. So this is your bit rate. From your bit rate, you should be able to get the T, the bit period. Waveform amplitude is given, noise power spectral density, and not over 2 is 0.5 times 10 to the power minus 11. Calculate and compare the average bit error probability. So you are given the error function. Okay. So when you're given the error function using equation like this, you know that the Z value should be larger than 2. Okay. Okay, you're given EC. From here you can get your T and not, so you should be able to calculate your PE lah. Okay. So here you can, for FSK, you can use both, calculate both synchronous and asynchronous. Okay. But ASK and PSK, we have only one equation. Okay, so the other number 4 also to calculate the bit error rate. Okay, so you can notice here the how the question on bit error rate is asked. Okay, basically you're given equation, just find the values for the parameters inside the equation. Okay, so and then find the bit error rate, performance and bandwidth requirements. Illustrate block diagram of FSK uses two intermediate ASK waveforms. So this one is also in the slide. And then another one, block diagram of BPSK receiver. Input signal is sine omega CT. The coherent carrier recovery frequency detects and generates. That's the figure below. Okay, so this is your block diagram of PSK. Okay, so instead of cosine, our input here is in sine. Okay, please. Okay, so write the mathematical representation of the outputs at point A and point B. Okay, so here you need to solve lah. When you multiply the receiver with our input, sine omega C and minus sine. Okay, you should be able to find what is your A and B. Okay, this point A should have the higher harmonics. Point B should be able to get just the DC voltage, where then you will translate whether it's 1 or 0. And then if input now change to minus sine omega CT, okay, what is the output at point B? So here you can notice there's a difference in our example. In our lecture, we use cosine omega C and minus cosine. In this, because it's final exam, not too direct, so it gives you sine and minus sine. Okay, the two inputs or the two BPSK signal. So you should be able to do the, basically the concept is similar. Should be able to solve using the same approach. Okay, and then the QPSK, this is the block diagram of QPSK receiver. Okay, this one we will look at this next week, inshallah, with all other questions related to multi-level PSK. Okay, I hope you can do the tutorial by yourself, try them. Okay, so that's it for today's lecture. So I'll see you next week, inshallah. We'll continue with multi-level PSK. And that's it for chapter 5. Yeah, not too long. And then we'll have a quiz as normal, as usual. And after quiz, we'll continue with the last chapter on multiplexing. Okay, if you have any questions that you're not clear, okay, you can just ask the question inside Telegram group or post the questions in e-learning in our essay question, where normally I ask you to reflect what you have learned on that day, right? Okay, so that's it. Assalamualaikum. Good afternoon and have a great day. Take care.